Hi, this is David, and this electric space heater failed me last winter. I like to use it in the garage. I also use it in the house occasionally on exceptionally cold weather. And I'm going to show you how to troubleshoot and replace a thermal fuse, thermal cutoff they're also called. We'll also take a look at them in a few other devices. Any electrical device that heats up is going to have some kind of protective device in it. And when they don't heat up, that's something to certainly look at. Thanks for watching. Here's an example of another one. It's a small, kind of a personal heater. And right down here you can see the thermal fuse. Again, these can be difficult to read. That's a fiber board behind there. Might look like metal, but it's not. Now, if you want to test out one of these thermal fuses, you just need a meter. And just go across the fuse. Put it on ohms. And you will find a low reading, and it's good, 0.3 ohms. Now some devices that have a heating element, such as a blow dryer, actually have a resettable fuse. That's what this is down here. So it doesn't need to be replaced if it does overload. As it cools off, it'll reset and operate again.
Now this is an antique. 70s somewhere. What they did is they had a little trim piece that sits over the screws that cover the access hole. I didn't find it, so I took this end cap off. So to take off 1, 2, 3, 4 screws here, and then we can work on this a little easier. So then off comes this little access cover, and now we have the workings. Okay, so the original thermal cutoff is located here between the power switch, or the control switch, and the heater. The heater itself, which is down here, it's located underneath this holder here. The idea is that you want to get the cutoff, so that heat transfers from this metal cover here to the cutoff. So one end of it would be hooked up to the switch, to the heat switch here, and the other end to this end of the heater. So we'll take this out and solder one end of the cutoff to this, and the other end will solder to this wire with the body of it on this metal surface here. Okay, here's the fuse up close. I chose a 157 degree fuse. Now the original part in this heater, in this space heater, was burned beyond recognition, just charred. So I picked a lower value. So I'd rather err on the low side, so if it tripped out, could potentially get some nuisance trip outs, but safety first. So what we're going to do is take our new thermal fuse or thermal cutoff, and we have to put some heat shrink tubing around part of it, a piece here, because we can't have the metal coming too close, switch contact. We can't have the leads on the cutoff potentially grounding against the that metal cover. So we'll put a piece of shrink tubing on there. Now as a test parts, never assume they're good. It's got 1.8 ohms on this new cutoff. It's good. I'm just going to grab a little solder here and tin these ends. I'm going to slide this insulating sleeve over here now. Now we can see how this is going to be mounted on here. Okay, I've got this soldered back together now. We'll plug things back in and get this in place. Okay, so we have it in position now. Reconnecting to the heater. I'm going to get this tightened back down.
See that gap up there between the on switch? Now watch as I turn this. The gap closes, closes, closes until those two contacts come together, and we're on, and we have heat. You can see the red. What happens is the top switch is on a really thin metal piece that basically separates as it heats up. Current flows through and it heats up, and then it turns off like it just did. Then it'll continue to cycle like that. These must cycle. If they run all the time, they're eventually going to overheat the thermal overload, the thermal cutoff, thermal fuse, whatever you want to call it. Thanks for watching this video. Stay warm.